Hello, hello. Thank you for having us. We're really excited to be here, and we've got some interesting things to share today. I'm Jeff.
And I'm Alex, and we're from the Angular core team at Google. Woohoo! Now, you might be wondering why we're dressed a little funny.
Yeah. What's that? Yeah, thank you. I don't know what you said, but thank you. Actually, we just got back from the year 2018. No, seriously, you'd be surprised the things we can do with Google X these days.
So let's see. It's May 2016, right?
2015.
15. Oh, okay. Yeah, we're in NG Vegas, right? You guys probably want to hear more about Angular 2, right?
No? That's old news. We're here to tell you about Angular 3 today. You see, after the great internet collapse of 2017 and before the great snow...
You can't tell them that. You'll create a space-time paradox. Angular might cease to exist.
Okay, well, never mind then. Maybe we should talk a little bit about Angular 2. So you and I, we spend all our time thinking about how data works in applications and how to simplify that and reduce boilerplate and make things more natural. So we could talk about the one app, the app where you can rent flying cars. What's it called?
Wings, with a Y. Like, some things never change.
Yeah, that's the one. They still haven't upgraded to Angular 3, but I think they do a pretty good job with data. So maybe we could talk about that one?
Yeah, why not? Like, a small paradox never hurt anyone.
All right, cool. So as of right now, May 2015, the core team and the community have been hard at work building the next version of Angular, Angular 2. And hopefully you've already seen some of the ideas, some of the videos and blog posts about how it works, and I'm sure you'll see a lot more at this conference. And we're not going to go too deep in this presentation on the general themes of Angular or the general implementations or APIs, but we did want to talk a little bit about the themes that motivated Angular 2 and drove the design.
So we've amassed a wealth of knowledge and experience from developing Angular 1 and working with all of you guys who build applications using it in production. And as a team, we've identified a couple of core themes that we're really going to double down on and focus on in the next framework.
First, we want it to be simple. We want it to be simple to learn, to reason about, and to develop with.
And it needs to be flexible to accommodate varying requirements of applications and third-party libraries.
Developers should be more productive as they learn, build, debug, and maintain applications.
And apps also need to be fast by default. You shouldn't have to know too much about how the framework works in order to optimize it.
And then the framework should be consistent with itself and predictable, so different parts of the framework behave somewhat predictably with other parts.
So the web has actually changed a lot since Angular 1 came out back in 2009. And we want the new Angular to reflect that. So for example, we now have something called web components, which are a native approach to building reusable elements.
Yeah, and so in the new framework, we wanted to understand those paradigms and take advantage of them and lay on them as much as we can without reinventing things they already do. So we looked at data binding, at scopes, at content projection, and we wanted to fall as much as possible into those paradigms. And that means less boilerplate code in your applications, fewer directives the core needs to wrap the DOM, and an overall simpler experience for developers.
And beyond web components, we've made improvements to the performance and the developer ergonomics in Angular across the board.
So that's all. Let's talk now about Angular 3.
Nope, sorry, we can't do that.
Okay. Well, we did say we'd talk a little bit about data in Angular 2. So Wings does a pretty good job. Maybe we should talk about that a little bit more.
Yeah.
So Wings is a company that rents flying cars, and I know everyone always says flying cars are just 5 years away, but trust us, it's actually just a couple more years away. If you hang on a little bit longer, you'll see them.
Yeah, so the Wings application lets you reserve flying cars, locate them, check in, bring up navigation because there aren't really any signs up there. And when you're done, you can finally review the car to let people know if it's a good model or if it likes to crash a lot. So let's talk a little bit about how the Wings application handles data.
Yeah, it's really simple. They fetch it and they bind it and they're done.
I think it's a little more complicated than that.
Okay, how so?
Well, what do you mean by fetch it and bind it?
Okay, I'll show you. So they have a server that returns JSON. So in my controller, I request that. The server sends back the JSON. I process it, parse it, dump it to the model, bind it to my view. Angular takes care of everything, and I'm done.
Well, yeah, Angular will take care of populating the data in your view. That's exactly how you would do it if you were using ngResource in Angular 1. But what happens if your server goes down for maintenance or something like that?
Okay, we're not quite done then. We need some error handling, so I should be able to tell my users if something goes wrong, maybe show them a message, and then retry the request until it succeeds.
All right, that's a little more complicated, but I think it's going to work. What if the user loads your application from Wi-Fi or from a tech conference somewhere and the HTTP requests just don't make it through half the time?
Okay, I hadn't thought about that, but I guess the requests would time out, so I could wait for them to time out and retry it. Since that can take a while, I should show a loading indicator until it's resolved, and the users will understand what's happening.
Okay, but what if they don't have a connection at all? This 2016, shouldn't they be able to use the app? 15. Shouldn't they be able to use your app online, though? Offline?
Okay, that's easy. I just cache the data that comes back from the server, and then they can use the app offline.
Okay, but what happened? Doesn't that mean your app is going to be read-only then? What if you need to synchronize changes to the backend when the connection gets back? What about authentication and authorization?
Okay, so it's a little more complicated than I let on.
So yeah, modern web applications have to deal with a lot more than just shuttling data from the backend into a view, and Wings is not an exception to that.
That's right. Users want to access applications on a variety of different networks with flaky, unreliable connections. And it's up to us as developers to take responsibility for delivering a consistent experience when these things happen.
So how can Angular help with that?
So like we saw, application data is complex, but Angular knows a lot about how applications are put together. So can't the framework just automatically solve everything and give you full offline applications? Unfortunately,
no, we can't. Angular only knows so much about how your applications are put together, and there's only so much time we have as developers in the day, even with access to a time machine. But what the framework can do is provide support and direction for various data challenges that applications face. So we took our experience working with data in Angular 1 and came up with 3 central themes to guide the development of Angular 2's data APIs.
First, we wanted to focus on the end user experience, the people using your application. What can we do to provide a robust experience for them, for the many kinds of applications they use, the many kinds of users in different environments, under different conditions?
We also want to avoid drowning developers in boilerplate code. Common tasks should be able to be expressed succinctly throughout your application.
And then we want to recognize that developers bring their own data to applications. So data looks different, it's structured differently, it moves around differently. We want the framework to play well wherever it comes from, however it's structured, and how it's changed. So taking these themes, we wanted to break that down into some best practices. And actually one of the reasons we went to 2018 in the first place was to see how applications had evolved and what kind of best practices emerged over time in the successful applications. So we wanted to break down what we saw into some concrete best practices, starting with interruption-free interaction. And by this, I mean that users should be able to keep using an app even when things go wrong behind the scenes, but still be able to do something with the app even if they do know that something is going wrong.
Right, so how you actually implement this experience is completely subjective to your application. It's likely that you may not be able to provide the full experience offline as you can online. But we think that where it's reasonable, the user should be able to continue what they're doing without really noticing that the connectivity has dropped and reestablished in the background. So we also think applications need to load quickly whether or not the user has a good internet connection. Now, loading an application while offline is still a really tricky problem, but it's more possible now than ever before with the advent of platform APIs like Service Worker, Local Storage, IndexedDB, and the application cache.
So with these lower level tools in place, it becomes a matter of establishing best practices, providing good framework support, and us as application developers providing thinking specific to our applications about how we can approach offline design, particularly at the beginning of an application, because this is hard to apply to an existing application later on. And then transparency. So that means don't try to hide when things go wrong from users. Just put it in a way, communicate to them in a way that is helpful to them, such as when there's stale data in an application.
So for example, if I rent a flying car in Las Vegas through Wings, and I tell the application, okay, pick me up down by the ocean where mobile networks are flaky, Wings will show me the car's location on a map and give me an ETA. If my phone has a bad connection, that position can get quickly out of date, especially if I've requested the sports model. In that case, Wings will interpolate the car's last known position and direction to estimate its current location and show me an indication of the uncertainty involved. The app is doing its best to keep me informed as a user while still acknowledging that it doesn't have perfect information.
And then we want to empower users. And this is more relevant to writing operations, mutations on data. If there's a risk of failure of writing to data, it's good to be able to try it and let the user try it, but make them aware that there's a risk that the operation won't go through. And then to provide good tools for the user to retry changing the data, canceling the change, or merging the change. This is particularly important when an application regains network connectivity and tries to synchronize the changes between server and client.
So Wings does this, for example, when you're reserving a flying car. It will actually let you do it offline. You can get a quote, you can make a reservation, and it'll do its best to provide it for you. But if the price changes or if another user has reserved the car that you were looking for, the app will show you the conflict and prompt you to accept the new price or a different car.
So in many apps, a lot of these operations can be safely done, particularly when you're just pushing data, not mutating an object. So we think it makes users happier and more empowered when you do provide this alignment. So we believe this is the future. These sounds come from the future. And so these are what applications look like in the future, but Angular can't do it all.
Yeah, for starters, we don't want to make assumptions about the backends that you guys are using or how complex your data model is. Even something that seems deceptively simple, like caching, can be really tricky to implement properly on a complex data model. And the desired user experience that you want to create varies greatly from application to application.
So one thing we're doing is relying on other libraries and services that applications are already using for their data, and working with the authors of those libraries to ensure that we have good core framework support to integrate with the ways their data flows and changes in applications. And then we want to reduce the amount of boilerplate by adding more features and hooks inside the framework, like in change detection and compiler and router, to facilitate integration and reduce boilerplate of doing these common integrations of data and applications.
And to make it easier for applications to get the user experience right, we're working on creating wrappers around browser APIs for local storage and other modern functionality to make them easier to test and to make sure that even the latest functionality fits well in Angular paradigms.
And lastly, to reduce the amount of friction in application of asynchronous data, we're going to standardize on observables in the core framework as well as the data libraries that we are building now. And observables are the preferred way of handling asynchronous events and values. And I asked Jaffer from Netflix to come up and talk a little bit about this. Jaffer won't shut up about observables, so he's the best person to talk for a few minutes about what they mean.
Oops. All right, so I want to talk a little bit about Observable. Observable is something that we use heavily at Netflix, and we've been using for the last 4 years for a whole variety of reasons. But let's start out by talking about something I think is more familiar to most of the people in this room. Who here in this room is familiar with promises? Quick show of hands. Quite a few people. All right. So I'm going to introduce you to a new type today, but first let's talk a little bit about how promises work. Promises are sort of they're like an asynchronous value, but they're represented in an object, and they'll eventually resolve to either a value or an error. And you can pass them around through your system, and you can chain other operations off of them, and you can depend on them that if an error occurs, it'll propagate that error up to where you can catch it. And so they're great. They're a huge improvement over callbacks for a lot of scenarios. And so it's kind of a way you think about promises, it's like a present that you can open, and you can sort of get out a value at the end of that, right? Well, today I'm going to introduce you to another type called an observable. And it's a little less like sort of a present that you rip apart and open, and more like a bag. And so here's how it works. If you want to get a value out of an observable, you sort of just ask it for it, and one will come out. And that actually works very, very similar to the way promises work, as you'll see in just a moment. But observables can do something promises can't. They can send you multiple values over time, and then eventually tell you when they're done. So what does that mean? Well, here's our example of a promise, right? We want to go and figure out how long the wait time is for their broken futuristic car. We're at the futuristic mechanic. And then we ask, and it goes off to the server, pulls it down from the cloud, and gives us a value. So we got to wait X amount of time. Now, with an observable, it's pretty much the same thing. So I want you to see. Notice one difference already, though, is that when I create an observable, I haven't already begun a network request. The difference between an observable and a promise is that an observable is lazy. You can create an observable, but it's not going to do anything until you subscribe. So I want you to notice here when we subscribe, it goes to the network, it gives us back an answer, same thing. The difference here is that the method's called subscribe instead of then. That's the only real difference. That and we wait to make the network request until we call subscribe. So not that big a difference than promises, right? But, as I showed you guys earlier, let's say that I want to retry, because promises are lazy, that is, if I want to retry, let's say I go to the database and I get back, the service rather, and I get back a value, and then later on I want to pull and I want to find out again, I can just resubscribe to that same observable and it will make another network request and send me the latest value. So we can see the time's gone down because we're waiting in line, right? And so you can use an observable, you can sort of reuse it to go and get values that are more up to date over time. Now, let's say instead of polling the server and grabbing the wait time after, every 200 milliseconds or 300 milliseconds, we want to actually listen to a WebSocket, right? So here we've got a WebSocket. Now we're looking for the current wait times. Well, when we subscribe to an observable, we can actually open up a WebSocket and sort of deliver those values over time. So as soon as we subscribe, we sort of turn over the bag, and then a network request is sent off, and a constant connection is established. And over time, we just keep getting better and better and more accurate wait times as people leave the queue or add the queue. And finally, when we're done, that third callback, see at the bottom there, is invoked, and that's our explicit signal to tell us there's no more values coming. So that's great. An observable can sort of keep a connection over for a long period of time and send us values. And, well, that's great, but what about if we decide, you know what, it's too long a wait. We want to go to some other mechanic. Well, we can do this. Notice that when you subscribe, you get this subscription object out. So I go var subscription equals subscribe. If after a while I decide, I'm tired of waiting, I can call subscription.dispose. And what that does is it's just like unhooking from an event, right, which is another stream of values over time. What that's going to do is the moment we call subscription.dispose, it's going to close that WebSocket and the observable is ready for use all over again. So promises deliver values asynchronously, so they deliver a value asynchronously, and they also propagate errors for us. But contrasting that with observables, observables can deliver a value asynchronously or synchronously. For example, if you have a result of a network and you want the observable to cache it, and then when you subscribe again, you actually just want the cached value, it can send it to you synchronously, which can help with performance in a lot of cases. And it will also propagate errors in exactly the same manner you're accustomed to with promises. So if you compose observables together and an error occurs in one of those observables, it'll just get forwarded up until you've got a handler somewhere to catch it. But we've got 3 additional behaviors that are really useful for dealing with data. One is observables are retriable, right? If you get an error and you just have if you've got a promise and you've got an error, there's no real way with just that promise to go ahead and retry the network request. Not so with an observable. If you get an error out, just call subscribe again and you'll send another request. And there are operators that you can execute over observables that will basically cause it to simply retry a certain number of times. And then you can basically fold all that retry logic into the observable. You just sort of define what your own retry policy is. And as I mentioned earlier, it can deliver streams of values. And really important for the way UI development works, it's cancelable. I mean, users change their minds all the time, right? We open up forms and then we might go try and load some data and then animate it in. But then halfway through, the fickle user decides, I want to leave. And they just X out. With a promise, you'd have to sort of set some state to sort of, because when your callbacks get called, you want to kind of not do the things that you were planning to do. Here with observable, you just call subscription.dispose and you don't have to worry about it. Everything will get cleaned up for you. So if you think about it, why are observables so important in user interface design? Well, most of the interactions in a user interface start with an event. They're followed by an asynchronous request. And finally, they end with an animation. And what's so powerful about observables is they're actually abstract enough to model all 3 of these different actions. And they come with a whole series of functions to allow you to smoothly combine them together. Now, the industry is moving towards using observables. Angular is standardizing on observables. React is also standardizing on observables for its data loading. And finally, this observable type is on track right now for JavaScript standardization. So there's probably guys out there, that sounds great, right? But there's probably a few guys out there who are pretty comfortable with promises, right? You like promises. You understand promises. And that's okay. What we want to tell you is, look, relax. You can take any observable and you can just turn it into a promise. It's as simple as that. And then it'll behave like a promise. You can get the last value. You don't need to think about anything new or learn a new thought. But when you decide that you come up against one of these cases where you need that extra flexibility, then you can start to learn about the extra power that Observable provides you and ease into it. So I'm going to turn it back over to Jeff here to tell you the rest about Angular data.
Thank you, Joffer. We're excited to be collaborating with Joffer and Ben Lesh from Netflix and some others on the next version of RxJS, as well as helping to push the spec forward.
Right, so we're going to look at some examples later, which are based on the RxJS library for observables, for those of you familiar with it. But just keep in mind the ultimate implementations will probably look different as we move forward with observables in Angular 2.
I wanted to give a special shout out to Ben Lesh for all the help he's done. He's in the corner here. Help he's given on helping us figure out how to leverage observables and also pairing on some of the new APIs using observables in Angular. So let's take a look at the core now to see some changes we made in Angular 2 to simplify some of the use cases that were previously complex, such as using async primitives inside templates or controllers like observables, promise, or other abstractions. And the first thing is this new feature that is specifically for promises, observables, and the like that makes it easy to put these values in templates, and it's called pipes.
So pipes are responsible for taking inputs from template bindings and unwrapping them or transforming them for the change detector and for the view. If you've ever used filters in Angular 1, pipes are conceptually similar, and they look very similar, but they have very different semantics.
For example, a new instance of a pipe is created for each binding, so this observable in a template gets its own pipe created for it. Whereas in Angular 1, filters were global singletons that were shared and didn't really have state. They just had input they operated on and processed it. So you could actually create a pipe that behaves like a filter, and there are a lot of good use cases like that, like if you want to render JSON a certain way or do basic transformations on data. But let's go beyond. Let's go into a particular pipe in Angular 2 that we show here called the async pipe and see how it works.
So async is a pipe that can unwrap an observable or a promise and provide its values to the change detector. When the observable pushes a new value, it'll get rendered on the next digest. But if a digest happens and the observable hasn't seen a new value, the pipe will tell the change detector not to dirty check the value.
So this is a nice performance optimization. So if something using async pipe, when the pipe tells the change detector whether or not the value's changed, it saves a dirty check time, which throughout your application, if you take advantage of this, then every time the change detector runs, it will skip dirty checking for any of these objects that explicitly say nothing has changed.
Yeah, it adds up.
So in our Wings app, we have some examples here where we run an observable of vehicles through the async pipe and then can look at them. But then we have this cool way of composing pipes together with the isAvailable example here, where I can pipe in the vehicles into async, and the output of that is just a list of vehicles. And the isAvailable pipe only shows the vehicles that I can actually rent right now.
So this may look really simple, and the differences with filters may seem a little insignificant. But what's most interesting and powerful about this example is that my controller is providing an asynchronous value to the view and doesn't need to worry about unwrapping it or passing new values along as they come through. In fact, the isAvailable pipe here doesn't even know that it's operating on data that was asynchronous. So we think pipes will help developers remove a lot of boilerplate code.
So by passing an observable, the values it emits are automatically pushed all the way through to the view. And you may be thinking, if you've used Angular 1, that well, anytime something like this happens from an asynchronous source outside of Angular, I have to call digest.
Right, and that's where zones come in. Zones are a way of tracking asynchronous operations as they flow through your application. Angular uses them to intercept all browser events, like DOM events, set timeout, XML HTTP request, WebSockets, any possible entry point into your application code.
So because Angular knows about the application code that's running, it can digest afterwards automatically, even for async operations like XML HTTP request or user events. Those automatically will get digested as well.
This means that as long as the new values on your observable come from something that can be correlated to a browser event, Angular will digest automatically. In most cases, you shouldn't need to manually digest, even if you're doing something really asynchronous.
So now that we've looked at a couple parts of the core, let's take a look at some new services that we're developing, built to make access and persistence of data better in applications, starting with the HTTP service.
So Angular has always strived to enhance the usability and testability of browser APIs. And we're continuing that with the data APIs in Angular 2. So let's look at the new HTTP API.
So the primary goals of this API were to make something simple, powerful, and testable. It should be easy to read it. It should be easy to write it. And we want it to fit within Angular paradigms, but not be bound with Angular, so you could use it outside of Angular and in different environments. So let's take a look at how it works. So at first glance, you probably say that it's a little bit similar to $HTTP, which it is. We call the HTTP function with a URL or a config object, and we can subscribe to it and it performs a request. But we gave some thought to how we could make this more powerful.
And one of the first things we did, of course, was standardize the new API on observables. So when we're calling the HTTP function, we're getting an observable back. And for basic usage, it actually doesn't look that much different from a promise. We're calling subscribe instead of then. We're still passing a success handler and an error handler that get called when the request succeeds or when an error comes back. But the real power of observables comes from when we want to go beyond this basic use case.
So consider apps that are commonly used on poor internet connections or with flaky APIs. It's probably a good idea to retry those connections as they fail. So the observable API that we're using makes it as simple as calling retry on the observable.
So in this example, the request to get the current wait time is tried 3 times before any errors are returned back to the application. And for use cases where you want to be a little bit smarter about retrying, you can use the retry when function to inspect the errors and determine what to do. So in this case, as long as the error is between 403 and 500, it'll keep retrying. Otherwise, it'll propagate the error and give up.
So the Wings app should always be ready for me to ask what the current wait time is. And by using observable composition and starting with an interval observable, we can perform a request every minute to see the current wait time.
So for the part of the application that's showing this expected wait time, we're creating an interval observable firing every 60 seconds, mapping that event that comes up to a URL, and then sending it to the HTTP service to make a request before we subscribe to it.
So in the app, I load prepaid credits every month so that I can keep going around without my car breaking down or running out of money. I like to check every once in a while to make sure I've got enough credit to get around. So Wings is a smart business. They want to maximize utilization and profits. And so they utilize something they call air traffic control pricing when there's a lot of riders and fewer flying cars in the sky. So when I look up my credits in the app, I don't care so much about how many credits I have at the given time. I care about how far they can get me.
So in Wings, they request the entire account object, which has this field called credits, and they transform it in their controller, dividing by the current meter price to get the distance that Jeff is able to travel. Then they use the async pipe to simply bind that into their view.
So in the part of the app where I request rides, I want to know what's going to cost me before I commit. And so the Wings app lets me type in the address where I want to go and is watching that as I type to guess what I'm going to finish typing and is continually returning a cost based on that guess.
So since I'm giving more information to the app with each key press, I can start by just binding to the destination input change observable, mapping that to a new URL with the current value of that field, and then using the flat map latest operator, the previous HTTP request is automatically canceled whenever a new keystroke comes in.
So in the future, it shouldn't be a surprise that beards are commonly accepted as a status symbol. And I want to make sure my avatar in the application always reflects that so my friends realize where they stand. So the app provides a nice feature of uploading my avatar and providing progress updates as it's being uploaded so that I can calm down and be assured that it's actually being uploaded.
Right. So in the HTTP API, this is as simple as passing an upload observer to the HTTP function. It'll get called, it's on next method here, with every progress event that comes back from HTTP. So that can be just bound to a progress bar so Jeff can be assured that his beard is making it online. So last but not least, one of the reasons the Wings app is so successful is that the developers rely on good testing practices. With the HTTP library, testing is largely as simple as observing the backend for new connections and responding to them with different outcomes to make sure that the app can handle different situations.
So I'm going to look at an example test, and there's a lot of code, but this is the most code in the whole presentation, so just bear with me for a moment. So we start using a standard testing, and we inject our backend for our HTTP library. Also a service that the Wings has created that has some shared configuration and transformations for their API. And then we subscribe to the connections observable on the back end, which creates new connections every time a request is made. And inside our onNext for this observable, we're setting the outer variable of connection to the connection that comes in. So we always have a hold of the latest connection. And then we make a call to fetch this URL and subscribe to that. And in our handler here, we're setting the outer variable of text to the response text of the response. So nothing's happened yet until we did the request and subscribed to it, which created a new connection. And now, since that connection should be set to the outer variable, we can create a mock response to that connection where we have text of ping success. Finally, we can check that the text was set to ping success. So this is a little bit different than how tests are expressed in Angular 1 with HTTP. This allows you to express them more in-band, so you don't have to declare all the expected responses or requests ahead of time and then perform your requests. You can actually perform the request, then respond to it, so you can reason more clearly about your code or your teammates' code. But there are cases where the previous design is more helpful, like if you have several tests that have the same request and response, you just want to test something else with it. You can still do the same way using the technique we showed here, where you just subscribe to the connections, and as soon as a new one comes in, you can respond to it, and then the response will be handled with that. So you could throw that in a before each block, for example.
So we'll also be building an Angular 2 WebSocket library with similar paradigms to HTTP, but with a deeper focus on streaming data as the first-class use case. And we'll add some helpers to make creation and reconnection of WebSockets more testable.
So in addition to the core HTTP and WebSocket APIs, we're going to work to support more modern web technologies. And IndexedDB is one of those technologies where we think we can add some value. And if you're not familiar with it, IndexedDB is a data store in the browser that's structured, it's queryable, it's indexable. You can have version schemas with it, you can do querying by keys or index, and you can use transactions to update data.
Right, it's incredibly useful as a technology actually for building offline applications, but the browser APIs for IndexedDB are not very testable, and they're a bit rough around the edges, particularly around managing the schema version and executing transactions. So we feel in Angular we can provide an interface to it that handles a few basic use cases like caching in a simpler and more testable fashion. For example, one thing we'll do is make the read API return observables instead of relying on DOM events. Of course, developers will always be free to bypass the Angular abstractions and work with IndexedDB directly.
So in addition to wrapping IndexedDB, we're also providing wrappers for local storage and session storage to add some more testability in line with other Angular paradigms, and also to provide an observable I/O interface. So in the past, one of the biggest challenges in offline web applications was cold loading the application in the browser without a network connection. And developers had some choices in how they could accomplish this. You could publish your app to an app store where everything gets downloaded, or you could use app cache, which worked, but it was kind of hard to use.
And that's all changing, though, thanks to a new browser feature called service workers. A service worker is a background task that runs in the browser. It persists, it's started on demand, and it can intercept and handle network requests for applications. And this makes a great offline experience possible. And we're excited to explore how we can best support service workers in Angular.
And we're still early in working out the details of this, and there are lots of moving parts of the framework that would need to integrate with a service worker implementation, such as our CLI to generate apps. But we're confident that we can come up with some ways to give developers a way of providing basic configurable support for offline loading with minimal effort. So let's move on. Let's talk about some upcoming APIs that we're starting to think about, but we're still really early on. And like everything in this presentation we already talked about is going to change. Angular is still evolving pretty quickly. But the things we're talking about now, we're just starting to think about, but we want to let you know that it's on our minds and they're problems that we're considering. So these are definitely going to change, but you can't go back in time and change history and expect the future not to change a little bit, right?
Yeah. So in order to help users understand if their network is making it difficult for them to request a vehicle, the Wings app needs some insight into the current network state, including latency and throughput. Unfortunately, in 2016 here, today's browser APIs don't provide, Today's browser APIs don't provide that much insight into network state.
So we think that with Angular's knowledge of all application network activity, and with some forthcoming browser networking info APIs, we can provide some basic heuristics and try to give applications a general idea of the quality of the network at any given time, so they can use this data, like the Wings app can use it to help know if the network is strong enough to confidently request a ride and that it will show up.
Right. Next, we'd like to talk about another challenge faced by web applications, which is prioritization of effort. For performance, applications should always prioritize the work needed to satisfy current user needs over background operations or other operations that are less critical. For example, when navigating to my account view in the Wings application to see my past rides, above the fold content should be processed and rendered first before the remaining components below the fold are handled. Since the view shows an infinitely scrolling list of 1,000 rides because I love flying cars, loading the last few dozen should take precedence over deserializing and instantiating the whole list.
On the flip side of that, when all the views are loaded and the user sees what they want to see, and they're not actively interacting with the application can and should do some things to anticipate their future needs. Like, for example, the infinitely scrolling list. If they've got the data they need for the immediate view, the application could begin fetching the remaining items and cache them to minimize latency if they start scrolling again. And then, since it's likely I'll click on one of the first few items in the list, the application could know to prefetch the 3 models that I might most likely to click on, so that when I do navigate to them, it's a lot more responsive and snappy. And beyond that, if I want my whole application to be offline, I could cache other parts of the application that I haven't even navigated to yet, so that I can navigate to them later and see at least some portion of my application model.
So these are optimizations that applications use right now, but they take a lot of work to get right. But we're exploring ways we can let applications hint to Angular how work should be prioritized, both during rendering and for tasks that have to run in the background when the user is not interacting with the application.
So we've talked a little bit about giving users cues when things are going wrong behind the scenes. In order to make this simple, applications need access to additional info beyond the data itself that comes from services. For example, a Wings user might want to know how recently the current price for a ride was updated in the application.
So we're working on standardizing a simple approach of associating metadata with values and exposing that to views. For example, if a view can know that a value came from cache, it could choose to display a message telling the user that the value might be stale.
So for parts of the Wings app where authentication is required for making data mutations, I should be able to know that in the application. Like when I'm adding credits to my account, it's a financial transaction, so it's something they're not comfortable with me doing offline optimistically and synchronizing it later. So the app provides that information to the view, and the view can disable the input, so I can't actually change my credits now, but I could see the cache value of what they were before, and I could be notified when the server verifies my authentication state and establishes connectivity, so I can update my credits.
So lastly, I want to mention one of my own projects, which is called Streamy. And Streamy is a Dart data access library. Now, if you don't use Dart, don't worry, we're going to be porting it to JavaScript pretty soon. Streamy gets its name from the Dart version of Observables, which are called streams. And it leverages that abstraction to solve some complex data access problems. So for example, consider an API call in a large application to fetch some data, which might be served from cache. With a traditional promise-based API, the data layer has to choose between returning a cached value, which is possibly stale and out of date, or making the user wait for a round trip to the server to get the freshest information. Streamy's solution to this problem is just to return both values, the cached one first, so the application can begin rendering. If the server comes back later and says nothing's changed, it's just saved a whole bunch of latency. But if the server says there is in fact an update, we can deliver it to the application, and Angular will take care of inserting it into the view that we've already built. So Streamy is already used as a data access system for several large apps at Google, and we'll be porting its concepts to a JavaScript library pretty soon. Our goal is to use it to explore a more opinionated approach to data and offline technologies outside of Angular core.
So beyond these near-term APIs, we're constantly looking for new ways to reduce boilerplate and to provide a better experience for end users and for developers in the core of the framework. And we'll be sharing these designs and these ideas on our social media channels, our personal ones, our team one, our blogs. All the information is pretty spread out right now, and we're working on consolidating that more. So stay tuned to see how they develop. And so, as we mentioned earlier, Angular can't begin to solve all these problems by itself or in the core. Application data is it varies too much. And so, we've been working with some community projects like backend services or data libraries to ensure that we can provide nice integrations with the core for them and reduce the amount of work they have to do to play nice.
So one project we've been working closely with is Falcor from Netflix, which Jafar will be speaking about later in the conference. Their experience integrating Falcor with Angular 2 has provided us valuable insight into how to design data APIs to make it easier for third-party libraries to get their data into Angular.
And they've provided great insight on how we can improve the framework as well as how we can leverage observables in the framework.
We've also been working with a project called LoveField. They're an open-source query engine based on IndexedDB. Happens to be written by some other Googlers. LoveField provides a full SQL-like query syntax on top of IndexedDB's more limited operations.
We're also collaborating with Firebase, and many of us have already benefited from David East's work. I guess there are other people involved with it too, right? Okay. On Angular 1 with the Angular Fire library. And we're already working with them to see how to integrate with Angular 2 and see how that will work. In fact, the integration has been so simple that David East is worried he's going to run out of work. So that's all. Thank you for listening to us. We've covered a lot at a high level. Everything's still evolving, so just follow us to stay in touch. But please feel free to email us or follow us and tweet at us and open issues on our GitHub projects. Send homing pigeons. I think people still use homing pigeons in 2015.
Yeah, that's still a thing.
Okay.
And finally, Jeff and I are going to be, in the other room there after this talk, and we'll be around here at NG Vegas for the next couple days. So feel free to come up and say hi. If you ask nicely, we might even take you for a ride in a time machine.
Thank you.